today's session, we are all going to learn about the sampling methods. So, before I begin the sampling methods or the techniques of sampling, let's understand the coefficient of variation. The aim of such concept is to measure the relative measure of variations, and that is exactly called the coefficient of variation. It means that how frequently the values used as a relative measure of variation, and that is exactly called the coefficient of variation, which was denoted by a capital C and capital V dot. This measure is also reflects the ratio of the standard deviation to mean, which mainly expressed in a percentage. And coefficient of variation is equal to standard deviation by mean into 100. When the coefficient of variation is less in the data, it is said to be less variable or more consistent. So let's consider one of the example to understand the concept of coefficient of variation. So consider the following data which relate to the mean daily sales and the standard deviation for four regions. First regions is first to four mean daily sales rupees in thousand, that is 86, 45, 72 and 61, and the standard deviation is also given in rupees in thousand, that is 10.45 and so on till fourth reason that were that was 11.32. The main is to determine the coefficient of variation and state which region is more consistent in terms of the daily sales. So we need to calculate the coefficient of variation of the four regions, that is for the first, that is standard deviation by mean into 100. So 10.45 by 86 into 100, which is equals to the 12.15. Same concept or procedure has to follow to calculate the coefficient of variation in region 2, that is standard deviation, which is equal to the 5.86 by 45 into 100, that 45 is mean, that is 13.02. For region 3, that is standard deviation, that is 9.45 by 72 into 100, that is 13.25, and 11.32 by 61 into 100, that is 18.56. As standard deviation for the third region is 9.54 rather than 72. So as the coefficient of variation is minimum for region 1, that means the more consistent region is region 1. That means the smaller or the less the value would be, the more consistent in the case of coefficient of variation. So let's begin with the concepts of sampling techniques or methods. So the first one is population and sample. Population refers an entire group that a particular researcher wants to draw a conclusion about the study or about the situation, about any sort of circumstance. But a sample is a specific group that a particular researcher will collect the data from a selected or a specific group, and that is called sample. The size of the sample is always less than the total size of the population. So in research, population doesn't always refer to people. It can also mean a group containing the elements of anything a particular researcher wants to study, such as object, events, organizations, countries, any other organisms. That could be called a main difference or reflect the difference between the population and sample. You can see in the particular image where the population is a large entire group, and from the population the researcher has selected a specific group so that he or she could collect a data from that specific or a selected group of people. This is how the examples of the population and the sample. So the population refers the advertisements for IT jobs in the Netherlands. So what would be the sample? The top 50 search results for advertisement for IT jobs in the Netherlands on 1st May 2020. So that means advertisement, so we can refer to a top 50 search results of advertisement, and that could be the sample. The next example would be the songs from the Eurovision Song Contest. Sample of winning songs. So we selected a specific type of the song, that is winning songs from the Eurovision Song Contest that were performed in English only. The next example would be the undergraduate students in the Netherlands. So the 300 undergraduate students from 3 Dutch university who volunteer for your psychology research study. So that would be the samples from considered from the population. The next example, all the countries of the world. That means what would be the sample of this example? The countries with published data available on birth rates and GDP since 2000, and that sample to be considered from those countries. So the next section is a population parameter versus sample statistic. The population parameter refers a numerical value that describes the entire population. That means every member of the group are included in your study. It is usually written with the Greek letters. That means it is a fixed value, but of course sometimes it could be an unknown value, because measuring the whole population it could be difficult. So the common symbols would be mean, that is mu, standard deviation, that is sigma, proportion, that is p. Suppose a researcher studies the average height of all students in India. So population, what would be the population? All students in India. What would be the population mean? That is height, 162 centimeter. Here in this particular example, 162 centimeter is the population parameter, because it describes the entire population. That means all student heights that would be in India, which refers a 162 centimeter. The next concept is a sample statistic. It also refers a numerical value which calculated from a sample. That means a smaller subset of the population. And it is usually written with the Latin letters and used to estimate the population parameter. Common symbols of the sample statistic would be the X bar, that is sample mean, sample standard deviation, that is S, sample proportion, that is P bar. Let's take an example to understand the sample statistic. Instead of measuring all students in India, a researcher measures only 500 students. So sample would be 500 students. Sample mean height would be X bar is equal to 160 centimeter. So 160 centimeter is a sample statistic because it is calculated from only a sample. These are the real life examples of the population parameter and the sample statistics. So a situation would be the average salary in a company. That means what would be the population parameter? That is average salary of all employees. Sample statistic, that is the average salary of the 50 surveyed employees. Election support, that is the population would be the percentage of all workers supporting a candidate were included in the study. But what would be the sample statistics is only the 1,000 voters would be selected which would be surveyed you can say voters by the researcher. Average exam score, average score of all students in the school, that is a population parameter. Sample statistic is the average score of 30 sampled students. So 30 would be the sample statistic, that is average, a mean score of 30 students. The next concept is the census and sampling. What is census? Census is a process that a research that is a process of how the particular researcher is collecting the data from every member of the population. So it's just a process of collecting data from every member of the population, whereas the sample is the process of collecting data from a subset of the population. So in a census, every member of the population is included, but in sampling, a small group of individual or a selected group of individual is chosen to represent the population as a whole. So this is a difference between the census and sampling. Census includes collecting data from every single member of the population, but sampling includes collecting data from the subset or a selected group of the population. Census requires a large amount of resources and time so that a researcher could conduct the survey and collect the data. Sampling requires a few resources and it's quicker to conduct it only of and include in it's only and include a specific group or a selected group from the population. Census provides a complete and accurate representation of the population because it covers all the members of the population. But sampling provides an estimation or a general idea of the population based on the sample a researcher has selected for the study. Census can be more expensive, but sampling would be less expensive than the census because it only includes a specific group of population. But in case of the census, it is more expensive because it includes every member of the population. Census can be useful for the small populations or when a detailed information is required about the whole population. But sampling can be useful for the large population or when a general overview is needed about the population. In case of the census, the margin of error is very small, which covers the large population. But in case of sampling, the margin of error is larger than the census because the sample size is small than the population size. Now the question arises, what is margin of error? Margin of error is that degree of uncertainty that your survey results might have. So in order to reduce or increase that degree of uncertainty from your survey results, that exactly called the margin of error. So it could be more likely to be occurred, or it could also reflect the true figures from the whole population, and that degree of uncertainty that exactly called the margin of error that could be occur in your survey results or could not be. It could reflect the true figures about the whole population or it could not be because uncertainties might or might not show or reflect it. So example of census. So the first is a national population count. The government counts every person living in India during the census of India, as you can see in the image as well. School survey. A principal collects the height of every student in the school. Company salary record. A company records the salary of all the employees to calculate the average salary. Library books count. A librarian counts every book in the library to know the total number of books. So that exactly called census. But sampling, it's selecting a sample or a response from a selected group of individuals from the population, or which represent the whole population, or it's a process of collecting the data from the subset of the population, and that is called sampling. So what are the examples of sampling? That is election opinion poll. A survey asks 1,000 voters about their preferred candidate to predict the election results. The next example is a student survey. A researcher studies the 100 students from a university of 10,000 students to estimate the average study hours. Quality check in a factory. A factory tests 50 light bulbs from a batch of 5,000 bulbs to check quality. And the next is a market research. A company asks 200 or 2,000 customers about a new product instead of asking every customer. And that is exactly called the few sampling of a few examples that reflects the counts of selected groups of individuals. Now we can come up to the next section that call what are the sampling methods or sampling techniques. In statistics, the sampling method or sampling technique is a process of how a particular researcher studying the population by gathering information and analyzing that data. It is a base of the data where the sample space is enormous. So there are several different sampling techniques available, and they can be subdivided into two groups, and all these samplings methods may involve a specific targeting hard or approach to reach the selected groups of the individuals. So these are the two main methods, the probability sampling and the non-probability sampling. So when we talk about probability, classified into two main categories, four main categories: a simple random sampling, clustered sampling, systematic sampling, and a stratified random sampling. But in case of the non-probability sampling, a convenience sampling, consecutive sampling, quota sampling, purposive or judgmental sampling, and the snowball sampling. So let's have an overview of all these types and methods of sampling. So let's talk about the methods of sampling. The probability sampling method. Probability sampling method, it refers to some form of random selection of individuals. So in this particular method, all the eligible individuals have a chance or an equal chance of selecting of the samples from the whole sample space. So this method is more time consuming and expensive than the non-probability sampling method. And the main advantage of this method that it guarantees the sample that should be representative of the whole population. So the non-probability sampling method is a technique in which the researchers select the sample based on the subjective judgment rather than random selection. So in probability sampling, the particular researchers randomly select the individuals for their study or by gathering the data. But non-probability sampling technique, it select the sample based on the judgments rather than considering the random selection. So in this method, all the members of the population have a chance to participate in the study. So the first technique of the random probability methods, the first one is a simple random sampling. In this particular method, every item in the population has an equal a likely chance of being selected in the sample, and that is exactly called simple random sampling. Since the item selection is totally dependent on the chance, and when the selection is entirely dependent on the chance, that method is known as the method of chance selection. As the sample size is large, the item is to be chosen or selected randomly, and that is exactly called the representative sampling. For example, in order to understand this concept, suppose we want to select a simple random sample of 200 students from a school. We can assign a number to every student in the school database from 1 to 500 and use a random number generator to select a sample of 200 numbers. Just randomly, we just pick a number from the 500, and then accordingly we select that sample randomly, and that is exactly called the simple random sampling. What are the strength and weakness of this method? It is free from the researcher errors. It is very easy to understand and apply for the study. The results can be generalized to the population or to the or generalized to represent the whole population. Weakness, it requires a complete list of the population. It could be costly and time consuming process. It's not suitable for a large organizations. The next method of probability sampling is a systematic sampling. In this particular method, the items are selected from the target population by selecting the random selection point and selecting the other methods after a fixed sample interval. It is calculated by dividing the total population size by the desired population size, and accordingly we get the exact figure. Suppose, let's to understand this concept, suppose the names of 300 students of a school are sorted in the reverse alphabetical order. To select a sample in a systematic sampling method, we have to choose some 15 students by randomly selecting a starting number, say 5, and from number 5 onwards, we select every 15% from the sorted list. That means 5, then again 10, 15, 20, 25. So on these numbers, if any individual exists, we select that particular individual for the study by gathering the data or information from them. So finally, we can end up with a sample of some students, and that is called systematic sampling. What are the strength and weakness? The strength of this method is very simple and quick to conduct. It also ensures the evenly distributed sample. It less costly than the random sampling. Weakness, it could be a risk of errors if there is a pattern in the population list. Less random than the simple random sampling. The next category or method is a stratified sampling. In a stratified sampling method, the total population is divided into small groups to complete the sampling process. And that small group is formed based on the few characteristics in the population. It could be based on the any other variable like age, income, etc. So after separating the population into a smaller group, the statistician randomly picked the sample. For example, there are 3 bags A, B and C each with different balls. Ball A has 50 balls, bag B has 100 balls, bag C has 200 balls. we have to choose a sample of balls from each bag proportionately. Suppose 5 balls from bag A, 10 balls from bag B, and 20 balls from bag C. So this is how we can choose. That means we can choose 5 balls from A, 10 balls from B, and 20 balls from C. That means we have divided by 10 of all of the number of balls in their respective bags, and just we have stratified, divided that groups into small numbers. That is 5 balls from A, bag A, 10 balls from bag B, and 20 balls from bag C, and that is exactly called a stratified sampling. But are the strength and weakness of this method? It ensures the representation of all subgroups. It is more accurate than the simple random sampling. It reduces the sampling errors as well. The one of the weakness, it requires a detailed population information. It is more complex as compared to the other methods to organize the data. It is a very time consuming process because we have to segregate the entire into a smaller group of people, and it would be a very time consuming process because it's totally based on the characteristics of the population. Now the last category is of the probability sampling is a clustered sampling. In the clustered sampling method, the cluster or the group of people are formed from the population set. That means the group has similar significatory characteristics. They have an equal chance of be a part of the sample, of be a part of the sample of the study. And this method uses a simple random sampling method for a cluster of population. Let's take an example. An educational institution has 10 branches across the country with almost the number of students. If we want to collect some data regarding the facilities and other things, we cannot travel to every unit to collect the required data. Hence, we can use the random sampling to select 3 or 4 branches as cluster and collect the data from the respective selected branches, and that is exactly called cluster sampling. What are the strength and weakness of this type? It is cost effective for large geographic areas. It is easy to administer because it also requires a few resources. Few weaknesses of this method. It refers to a higher sampling error, and cluster may not represent the population well, and it is less precise than the stratified sampling. So this is a diagrammatic presentation where the simple random sampling, there are 9 candidates and we just randomly selecting the number of candidates from the population. That is called simple random sampling. When we talk about the systematic sampling, so we have a 12 candidates and we just referring a systematic sampling by choosing any even number or an odd number, right? So if we look up, we have chosen odd numbers and one even number. That is called the systematic sampling. Stratified sampling, we have you can see the 12 persons of the population, and stratified we just selecting any numbers according to the characteristics. The next one is a clustered sampling. So we have just there are 12 branches, and accordingly we have selected out of the 12 the 4 branches as cluster, and accordingly we collect the data from the population. Now we can come up to the next type of sampling, that's called the non-probability sampling types or methods. So the first one is the convenience sampling. In a convenience, in this particular method, the samples are selected from the population directly because they are conveniently available for the researchers. So it means the researcher collect the data according to its convenience. So the samples are easy to select, and the researcher did not choose the sample that outlines the entire population. Let's take an example to understand this concept. So in researching a customer support services in a particular region, we ask you a few customers to complete a survey on the products after the purchase. This is a convenient way to collect data, but still we only survey customers taking the same product. That means while considering to select the customers who prefer the same product, it refers the convenience sampling because that are available for the researchers. So at the same time, the sample is not representative of all the customers in that respective area or region. What are the strength and weakness? So the strength are the quick and inexpensive. It is very easy to apply or implement, or it is very useful for the pilot studies. Few weaknesses are high risk of errors or bias. Results cannot be generalized in an organized manner. It has a low reliability of results. Let's talk about the next type is a consecutive sampling. So consecutive sampling is very similar to the convenience sampling with a slight change or variation. The researcher pick a single person or a group of person for sampling. Then the researcher researches for a period of time to analyze the result. It could be it could be days, it could be weeks also, it could be month also. And once it pass on, it move to the another group if needed. If the results are not accurate, it move to another group after a certain days or month, etc. That is called a consecutive sampling. When in a month the researcher has analyzed the result. If it is not appropriate, then after the 1 month they again move to another group if needed. That is called the consecutive sampling. For example, consider a finance researcher investigating the spending habits of customers at a local bank branch. So, due to the time differences or the time constraint, the need for timely data, the researcher opts for a consecutive sampling approach. So, over a course of month, the researcher approaches the customers at the enter the bank and invites them to participate in the study. Those customers who agree and meet the inclusion criteria, that means having an active account or being at a certain age, are consecutive included in the sample. And this method allows the researcher to efficiently collect data from customers who are readily available during the regular banking hours, and that's called the consecutive sampling. As it is a somehow, if it is a study of 1 month, so using this approach the particular sample can easily collect the sample within a month according to its convenience, which are available in the respective city or region or any bank or institution. What are the strength and weakness of this approach method? That is, it is quick and inexpensive. It is very easy to implement and useful for the pilot study, as the same advantages could be the high risk of base results cannot be generalized and low reliability of results. The next category or the method is quota sampling. In the quota sampling, the researcher forms a sample that includes individuals to represent the population based on a specific traits or qualities. The researcher chooses the sample subset that brings a useful collection of data which generalize the entire population. Let's take an example. Let us assume that we need to know about the career goals of the university students. More particularly, the differences in the career goals among freshers, juniors, and the seniors are to be examined. Suppose the concerned university contains 10,000 students and can be taken as our population. Now we have to divide our population of 10,000 students into categories such as freshers, juniors, or seniors. Suppose we found that there are 3,000 freshers, 30%, 2,500 juniors students, 25%, and 2,000 senior students, 20%. Our sample must have these proportions. It means that if we sample 1,000 students, then we must consider 300 juniors, 250, you can 300 freshers, 250 juniors, and 200 seniors. So we may start collecting sample from these students based on our proportion. That means we have segregated the students into three quotas, or that is traits, that is junior, fresher, juniors, and seniors, and accordingly we divide these samples according to the proportions, and then collect the data with these proportions, that is 200, 300 freshers, 250 juniors, and 200 juniors. What other strength? It is ensures the representation of certain groups. It is a faster and the cheaper method than the probability sampling. It is very easy to organize the results. Few weaknesses, that is selection error is also possible. It does not represent the true random selection of the candidates. It may results, or the results may not represent the population accurately. The next method of the non-probability sampling, that is purposive on the judgmental sampling. In purposive sampling, the samples are selected only based on the researcher knowledge, as the knowledge is instrumental in creating the samples, but there are the chances of obtaining the highly accurate answers with the minimum marginal error, and that exactly called the judgmental sampling or the authoritative sampling too. The next type is a snowball sampling. Snowball sampling is also called a chain referral sampling technique, and in this method the samples have traits that are difficult to find. So each identified member of the population is asked to find the other sampling units. That means it's through the friends, relatives, then relatives to relatives, then relative to their relatives. This is called a chain referral sampling. That means the particular sample, the particular individual refers to their relatives, then the samples are to be collected from the relative, then again they refer to some other relative, then again the researcher collect the data from their relatives. So this is exactly called a chain referral sampling, which known as snowball sampling. And those sampling units is also belong to the same targeted population, and that is called snowball sampling. What are the weaknesses and judgments? What are the strength and weaknesses of the judgment sampling? It is the strength are it is useful when the specialized knowledge is needed. It's mainly focused on the relevant participants and efficient for small studies. Few weaknesses are it is highly subjective, researcher based possible, and limited generalization of results. What are the strength and weakness of the snowball sampling? So these are the strength and weakness. So few strength are useful for hard to reach population. It also helps to locate the hidden groups. It is much more cost effective. A few weaknesses of this method: it is a high sampling base. It totally depends on participant network and represent the poor representativeness. So the next section is difference between the probability sampling methods and the non-probability sampling method. As I already explained the meaning of these two terms, let's focus on the other parameters or the aspects or criteria. So the next is, these are also known as the random sampling methods, but non-probability sampling are also known as the non-random sampling methods. These are used for research which is conclusive, but non-probability are used for research which is exploratory. Probability sampling includes a long time to get the data, but non-probability are the easy ways to collect the data quickly or in a faster way. When we, in case of the probability sampling method, there is an underlying hypothesis in the probability sampling before the study starts, and also the objectives of this method is to be validate the defined hypothesis. But in case of the non-probability sampling method, the hypothesis is derived later by conducting the research study in case of the non-probability sampling. So the hypothesis can also be built up or generated during the research study. But in case of the probability sampling, hypothesis to be generated before the study starts, and then the objectives of the method of the main objective is to validate that defined hypothesis. The next concept is a sampling distribution. Sampling distribution is also known as the finite sample distribution, and it also refers a probability distribution of a sample statistic which is based on the random selection of the given population. It also represents the distribution of the frequency, that how the researchers spread apart the various outcomes will be for the specific population. Since the population is too large to analyze, you can select the smaller group or repeatedly sample or analyze them. And the gathered data or statistic is used to calculate the likely occurrence or probability of an event. So there are few important terminologies in sample distribution. The first one is status. It is refers a numerical summary of a sample like mean, median, or standard deviation. Parameter, it refers a numerical summary of the population which is estimated using sample statistics. Sample, it is a process of collecting the data from a subset of population. What is population? Where the every member of individuals are included in the study to build up or come up or describe conclusions about the whole population. Sampling distribution, it is a distribution of statistic referring the mean, standard deviation, mode across the multiple samples taken from the same population. Central limit theorem, it is a fundamental theorem in statistics which states that the sampling distribution of the sample mean tends to be approximately normal as the sample size increases. Regardless the shape of the population distribution could be what could be. And anyway, standard error, standard deviation of a sampling distribution representing the variability of the sample statistics around the population parameter. Base, it is a systematic error in estimation of a value or any conclusions which leads to a changes of the estimated statistic from the true population parameter. And the next concept is a confidence interval. It refers a range of values calculated from sample data which are likely to contain the population parameter with a certain level of confidence level, that would be 1% or 5%. Sampling method, it refers to a techniques used to select a sample from the population, such as random sampling, stratified or cluster sampling, etc. The next is inferential statistics. It is a statistic method. It refers to all those statistical methods and techniques which are used to draw the conclusions or make inferences about the population based on the collected or a sample data. The next concept is a hypothesis testing. It also refers a statistical method for making decision or drawing conclusions about the population parameter which are totally based on the sample data or and assumptions about the population. So the next concept is a central limit theorem. So as you can see, the population which classified into four expects the population with strongly skewed distribution, and you can see the flatter curve which touches and the y-axis and immediately downfall to the x-axis. Sampling, the next category is the sampling distribution of mean for n, that is the number of two observations. So you can see the skewed distribution which is shown, which increases, begin from the origin, increases and immediately its downfall. The next one is a sampling distribution of mean in respect of 10 observation, that is the more flatter than the rightward shift of the curve. But the sampling distribution of mean for 25 observation, that is called a positive skewed distribution curve. That how to calculate, that is z is equal to the you can see the value that is standardized of this, it's called a sample mean, that is minus the population mean by the population standard deviation, and the n is a under root n is a sample size. So once we get the values, we can easily find the z score. So central limit theorem is one of the most important theorem of statistics, and according to this theorem, the selection would be based on random basis, as by considering the n number of size taken from the population with the population mean and variances, then the sampling distribution of the sample mean tends to be normal distribution, with mean and the variance as the sample size if to be large. This formula shows that how many standard deviation a data point that or any sample mean is away from the population mean. Positive z-score indicate values above the mean, while negative z-score indicate the values below the mean. Follow the normal distribution with mean 0 and variance 1. That means the deviation or the variation in z-scores follow the standard normal distribution. So according to the central limit theorem, the sampling distribution of the sample means to be a normal distribution, as sample size tend to be large, that is n is greater than 30, that n is a sample size and the particular limit is 30, it should be greater than 30. Let's take an example to understand. Mean and standard deviation of the tax value of all the vehicles registered in a certain stage are that is population mean, that is equal to rupees 13,525, and standard deviation, that is rupees 4,108. Suppose a random sample of size 100, so that means n is 100, are drawn from the population of vehicles. What are the mean and standard deviation of the sample mean, that is x bar? So hence n is 100, that is a formula which has been stated that the population mean is equal to the sample mean, that is equal to 13,500 to 5, and the standard deviation of the population, that is equal to the standard deviation root n. So standard deviation, that is 4180 by root 100, that means standard deviation is 418. So when we put the values into the formula, we can easily calculate the Z scores. So that you have to perform this task. The values is already given in the questions and in the solution as well. You just put the values into the z-score formula which has been mentioned in the central limit theorem. So once you put these values into the formula, you can easily calculate the z-score value. Now we can come up to the types of distribution, that means sampling distribution. There are three main types: sampling distribution of mean, sampling distribution of proportion, and the t distribution. So let's have an overview of this with the help of example. So sampling distribution of mean is a most common type of sampling distribution. So for any population with mean and standard deviation, so where the mean is referred to a center of the sampling distribution of mean which is equal to the population mean. So the condition of the sampling distribution mean where this population mean is equal to the sample mean. That means there is no tendency of the sample mean to fall systematically above and below, because population mean and the sample mean are both equal. In that case, the raw data is skewed. So mean of the sampling distribution, we can say it a unbased estimation of the population mean. Standard deviation of the sampling distribution is standard deviation by root n, where the n is a sample size. So these are, that means population standard deviation which is equal to the standard deviation by root n. That means it measures that how much the sample statistic changes from sample to sample. It is smaller than the standard deviation of the population by a factor of root n. Averages are less variable than the individual observations. The next concept is a t-distribution, that is t-test. A t-test is a statistical test which is mainly used to determine whether there is a significant difference between the means of the variables or not. The sample size is small, usually n is less than 30. The population standard deviation is unknown. The data is approximately normally distributed, and the test is based on the student t-test distribution which is developed by William Sainley Gossett. So the formula of t-test, that is equal to you can see sample mean by minus population mean, and S is a sample standard deviation by root n, that is sample size. And the value of t score is to be calculated using this formula. So this is an example. A company claims that the average battery life of a device is 10 hours. The researcher tests 16 batteries and finds sample mean 9.2 hours, a sample standard deviation, that is 1.6, and n is a 16. So apply the formula where the sample mean and population mean is also given. So we just put the values into the formula. So 9.2 minus 10, that is standard deviation is 1.2 and n is 16. So when we put the values into the formula, we can easily calculate the t-score value, that is minus 2. That means t is equal to minus 2. So now we need to calculate the next is to compare the value with the t distribution table and using the degree of freedom. So what is the formula to calculate the degree of freedom, which is equal to n minus 1. So when information is given instead of information given in the rows and columns, so degree of freedom would be calculated using the formula that is n minus 1. That is n is 16, 1 minus 1, it reached to 15. So while comparing the t distribution table, so we can examine the conclusion. The difference of means is statistically significant. That means if the t value is more than the t table value, that means the difference of mean is statistically significant. That means any hypothesis will be rejected. That means it refers that any difference between the variables is statistically significant. Types of t-test. So one sample t-test, it compares the sample mean with the known population mean. For example, checking if the average weight of students differs from 70 kg. The next test is an independent two sample t-test. It compares the means of two independent groups, comparing the average marks of class A versus class B. The next test is a paired t-test. Compare the two related measurements. For example, comparing student marks before and after training, and it refers a paired t-test. So when any study related before the intervention or after the intervention to estimate the you can say the estimate the particular variation in the treatment of a disease, then we can use the pair t-test. Before the you can say any teaching uh, program and after the teaching program, we can also use the paired t-test. When to use t-test? At sample size, when the sample size is small, population standard deviation is unknown, data is approximately normal, and when there is a chance to compare, is need to compare the means of the variables, then the t-test could be applied. The next section, what are the factors which affect the sample size decision? The first one is the population size. The total number of people and items in the group you are studying, that is more equally influence the sample size decision. Larger population requires larger samples, and if after a certain point it increase a certain point, the increase becomes small. The level of accuracy, that is margin of error, how close you want the sample results to be the true population value. Smaller the margin of error means larger sample size. The next is a confidence level, the probability that the sample truly represents the population. That means the common levels like 90%, 95%, 99%. So higher the confidence level, the larger the sample size required. The next you can say factor is a population variability, that's called standard deviation. If the population has a high variability, that means the researcher need a larger sample to represent the population accurately. If the population is homogeneous, the smaller population may be sufficient. The next is a type of sampling method. The methods likely simple random sampling, stratified sampling, cluster sampling can also influence the required sample size. The next is the research design. Experimental research design studies, descriptive studies, exploratory studies may require the different sample size too. Available resources, time, cost, manpower, sometimes restrict the limit of the sample size that is practically being used. The next is the expected response rate. If some respondents may not respond, the researcher increase the sample size to compensate that the missing frequencies. The next is a purpose of the study. The study is requiring the high precision that is in medical research need larger samples compared to the exploratory or the pilot studies. The next concept is the chi-square test. So before I come to the numericals or a broad perspective of formulas, it is very important to understand the basic terms which are used under the chi-square test. The first one is a parametric test, to test in which the population constants like mean, standard deviation, standard error, correlation, coefficient, proportion, the data tends to follow one assumed or established distribution, that's called normal, binomial, or Poisson, that's called parametric test. So any test which follow at least one assumed or established distribution out of these three, it becomes parametric test. And a non-parametric test which have no constant value of the population is used, but in parametric all the constant values of the populations used like mean, standard deviation, standard error, correlation coefficient, etc. But in case of the non-parametric test, no constant value of the population will be used, either mean, either standard deviation or correlation. In fact, data even does not also follow any specific distribution or any assumptions are to be made to such test. That's called non-parametric test. To classify good, better and best, we allocate the attributary numbers or marks to each category. And hypothesis, it is a definite statement about the population parameters. That's all for today. Thank you so much for listening this lecture. I will continue this chi-square distribution test in the upcoming session with the different numericals solved questions, and we look into an upcoming session. So till time, thank you and namaste to all.